For this section, we'll take the topic from the previous module even further by programming more advanced properties using the full potential of expressions. We'll start by building and using a base model for demonstration purposes. And then we'll carry out a much more detailed quantity takeoff compared to what we have done in previous courses. This time, we'll calculate not only the number of blocks, but also the exact amount of cement, sand, lime, and water required for the mortar, all using expressions. As always, remember to take the course at your own pace. Feel free to pause the videos and review anything you need as you go. And be sure to check out all the supporting materials. With that said, let's begin. Alright, so let's start off our new section, as always, commenting a little bit about what are the goals, what are we seeking to achieve over here, as well recommended expressions. It is going to be the continuation of our previous section, which was about classifications and properties, but we're going to delve a little bit deeper now into some properties, okay? For this case, I'm going to provide you with a model, which is already generated or pre-generated. It's this one file over here. I'm going to share with you this file in the next lesson, so make sure you download it. It's in ArchiCAD 28. It's a PLA file. If I go over here, properties, yes, it's a PLA file which was translated from Spanish to English. You can always annex your own library, and the file will look something like this. Okay, it's just a basic model, okay, which we're going to take into the example. And for this example, we're only going to quantify, but this time, instead of quantifying this in a generic way, as we already did in constructive solutions with ArchiCAD, the previous course, in this case, we're going to quantify this in a little bit more detail. Right over here, I'm providing you information about the masonry process of the wall, okay, of the walls we got over here. So what we're going to do is, you got the materials, which is going to be concrete block. For the mortar, we're using cement, lime, sand, and water in a ratio of these proportions, okay? For the number of blocks we have in 1 square meter, we have around 11.42 blocks. I made a small quantification over here. And the amount of mortar in 1 square meter is going to be 0.088 square meters. With these proportions, which we can find within these joints. Okay, so we got finally the quantification. Well, if you notice, this quantification is a little bit more detailed. We will extract information from this wall, the amount of square meters, and then how many blocks we can find, or well, in pieces, how many blocks we can find in this wall, this amount, how much mortar we require, how much cement we require in kilograms, or in bags or lumps, however you want to say it, how much lime, how much sand, and how much water we are going to use. Okay, so pretty much this is the main idea over here, to program correctly the properties. We get something a little bit more detailed. Okay, we're going to use tags. I'll show you how to reference the properties to the tags. And of course, we're going to extract all the information through a schedule. Okay, but yeah, the main idea here is to review the expression editor, how this editor works, how you can start linking information to generate something more advanced, something a little bit better, with the use of operators and functions and the different units we can find within this function. Okay, so pretty much this is what we're going to cover for this module. So for the next lesson, make sure you open up ArchiCAD, make sure you also download the model, and make sure you have the model opened up. Right, so once you open up the model, you got your ground floor. Right over here in worksheets, let's open that up. You can find the information about the materials, you can find the information about the number of blocks in 1 square meter. Keep in mind that the blocks we're considering for this example are hollow concrete blocks. that measure 20 centimeters in, I'm just going to draw it much easier. So this one has 20 centimeters in width. This one has 40 centimeters in length, and in height it's going to be around 20 centimeters. So these are the measurements for the blocks we're considering for this case, okay? For the materials, for the mortar specifically, we're considering a mixture of cement, well, I didn't translate this one, small detail over here, this is lime, cement, lime, sand, and water in these proportions, okay? If you want to use the basic units, you got kilograms, liters, but we're also going to do alternative units that we use, for example, in my region. Instead of cans, we use buckets. Considering a bucket is 19 liters, canister or bucket, however you want to refer this in your country. But the bucket is 19 liters. This is one unit of measurements we use in my region. And we also measure the cement lime in packages, or in other words, lumps. Okay, how also you want to refer this in your own country, feel free to do so. But the general international units, you can go ahead with this one if you want to use the metric units. Okay, otherwise you can always adapt this to your own needs. Okay, and when we open up the perspective, it's just a basic model. It's the same model we already used, if you remember, in constructive solutions with ArchiCAD. This was a project that we worked the first half or the majority of the course, the previous course. We used this model to create a constructive project and then document it, okay? But for this case, we only have 1, 2, 3, 4, 5, 6 walls. And the walls will also include, let's isolate this selection. I'm just going to right click it, show selection. If you notice, the walls include confined elements that will discount a specific area of the walls. So we also need to be careful with the quantifications. We want to quantify the net amount and not the brute amount. Just keep that small detail in mind. Okay, something we already commented and explained in the previous course, okay? But okay, let's start off with the basic stuff. First off, we need to create one classification and the base properties, okay? So first off, we require to create classification and the base property set. So let's go ahead, options, and let's jump into classification manager. If you notice, this is completely blank, so we start from scratch. Let's create a new classification system. Okay, this is going to be example. Okay, example project. Let's press OK. And let's simply create just a basic branch, which is going to be called masonry. Masonry, okay. Then we jump into something a little bit more specific. In the branch, let's create another one, masonry number 1. And let's name this hollow concrete block wall, something like that. Okay, I'm not sure if I said the order in English correctly, but this is the wall we're going to refer. Okay, you can always jump into the final, into more deep specific levels, but for this case, we're only going to use just a basic classification. Okay, now in Property Manager, what we want to do is we only want to create a basic group, new group, and we're going to name this hollow concrete block wall. Okay, it's just basic as this. Okay, let's press OK. Let's press OK. And now we could say that yes, we're pretty much done with the preliminaries. Don't worry about the walls. The walls already have a unique ID. Wall number 1. Okay, wall number 2, wall 3, 4, 5, 6. Everything has been named in this file. Okay, so we don't really need to do anything else. We just need to open the file, create the basic classification. And for the next lesson, now we can get into the most interesting part. Alright, so I got over here my original reference file where I got everything programmed. Okay. So how will expressions work? You can always link, for example, one property into another property. You can say that maybe this property over here, we use this as a base to generate another type of calculation, okay, or another type of formula. Everything is in Spanish, I apologize for that. But the idea here is that an expression, when you create your property, you will use complex, you can even go ahead and use really complex formulas, okay. Something amazing about ArchiCAD, if you go over here and create a new file, which I'm pretty sure you already noticed, you will have some properties that have predefined expressions. I believe that we already commented this, okay? And you don't really need to program anything. You can go ahead and use the template. For example, one of the best options we got in the template would be the amount of blocks or bricks you have in a wall, okay? You got three properties where you can specify the measurements for the wall. It's going to automatically calculate the mortar for you, the volume of the, well, you need to specify the volume, the mortar thickness, and it's going to calculate automatically the bricks for you. It's going to take one property, divide this by another property, and get the final result. For our case, what is the process we're going to do? First off, we're going to start off really simple, just getting the main area of the wall. Literally just an automatic translation into the property, okay? Then, for the amount of blocks, we will take the previous property and we simply multiply this by something, by 11.4, and then divide this by 1 square meter, and so on. If we have the second data, we then, for example, link and create another data, then we create another one, and so on, with really basic and simple formulas. If you notice over here, pretty much everything is quite simple. We only generate one operation, and pretty much that's it for this section. If you understand everything clearly, you can go ahead and proceed with more complex functions, okay? Let's go ahead with Property Manager, and let's start with the first option, which is going to be we want to extract and quantify how many square meters we got in a wall, which is going to be the first data over here. We need the amount of square meters, okay? So let's go ahead, new property. I'm just going to name this wall surface in square meters. Okay, let's create the property. And what we're going to do is in the value definition, we jump now into expression. Once you activate the expression, it's going to open the expression editor for you, where all the magic will happen. And right over here, you got three main buttons, one of which will open up the parameters and properties window. Another one which will open up the units window. Over here, these are the units. And the final, which is the operators. Long story short, this is how it's going to operate. If you open up parameters and properties, you will find a bunch of different properties. Imagine we're creating a schedule. What happens in schedules? You can always define which type of information you want to extract. So, for example, if you want to quantify the exterior surface of a wall, what you have to do is simply navigate over here, open up walls, find the correct parameter you want to take as a base. Let's say that we want maybe right over here, you find surface area of the wall, outside face. Remember, we got three different types of surface area. We got grass, we got net. So grass, it will quantify the wall as it was a whole element, without considering all the confinement elements we got in the wall. It's going to quantify everything as it would happen to be a solid whole element, okay? But if you quantify this as a net area, okay, what's going to happen is that it will quantify only this segment, considering the volume the confinement element takes. Okay, this volume, this one, and this one. It will discount the volume of all the openings of all the confinement elements. So what we want to do is we want to take, of course, it's going to be the surface area of the wall, outside face, net. Okay, this one. Okay, so right over here, once you link the parameter you want to extract and you want to save into this property, it's going to give you a small warning. Okay, the expression contains an error. Click the button to learn more. Okay, we're just getting started, but we already got an error. So if we click the button over here, it's going to tell you what type of error we get. It's going to tell you the expression results conflict, data type. Okay, we need to specify which type of data we're working on over here. Please review the data type, whether it's a string or an area or whichever data type. Okay, don't worry about the warning for now. You can simply press OK. Nothing really is going to happen. But what we have to do is right over here in data type, we need to specify what's going on with this data. Okay, so this data is an area, of course, because this is measured in square meters. So we need to specify this type of data is going to be an area. It's a surface expressed in area. And once you specify which type of data we got over here, you can clearly see that the warning, we don't get any other warning over here. Okay, you can go ahead, test this out, simply press evaluate over here. So 0 elements, yeah, well, it looks like everything works perfect. So once you are done, you have your expression set up. Let's press OK and let's now finally test it out. So in theory, we got the expression set up, but we're still missing something. If you remember, we skipped an important step. I haven't yet specified the availability for the properties. So before we proceed into defining the classifications for the wall, let's do something final. Let's go into classification manager. This classification will have available the property we just created. Let's just activate the whole group. So this property now will be available for the classification. Once it's linked, let's press OK and let's put the value to the test to see if it works properly. So I'm just going to take a test element over here, just a test wall. Let's model something basic, something like this. Okay. And for this case, let's select the wall. Let's proceed and assign the classification, which is going to be, in this case, hollow concrete block wall. And right away, you can notice that now the expression is set. Okay, it's available for this wall, but it's not going to tell us the amount right away. It's only going to tell us, okay, you got an expression over here, which will depend upon this wall. Okay, so what happens if you want to visualize which value you're getting from this expression? You can do a really simple step. Okay, we're going to do this step in the final part of this section, but let's jump a little bit before. Let's take the label tool over here, okay, or the tag tool, however you want to call it. Make sure that the tool will have a linked geometry method. And well, everything else really doesn't matter. Just make sure that it's a linked element. Okay, let's set the layer for the tag, which is going to be tags over here. And now you can simply go ahead. Let's press left click on this wall over here. For now, the tag will only extract the ID of this wall. Okay, so let's take a moment, double click the tag. Let's make this a title, a brief title, ID. Okay, and let's proceed and do the surface area, something like that. Okay, and let's add up the property we just created using the auto text function. So once you have written up the title for the property you want to extract, let's go ahead, insert auto text. Let's go ahead with properties. Let's open up hollow concrete block over here. And let's simply select the wall surface. Okay, let's add this up. And there you have it. It's going to automatically tell you that it's going to be 17.25 square meters. Okay, so yeah, this is how you can see if a property is properly working. Let's maybe change this wall a little bit over here. And yes, it's going to update. It's going to tell you you now have 7.28 square meters. Okay, so this is the first basic example. Keep in mind that yes, we can skip all this process and simply go ahead and with the tag tool extract maybe the same parameter. Okay, yes, you can do so, but this is an alternative way how you can do so, also using the properties function. Okay, so for now, just make sure that you extract, you create a property which its only sole purpose is going to be about extracting the data of the wall and saving the data inside the property. Okay, and for the next example, now things will get even more interesting because now we will start using operators and the correct units. Alright, so we have created the most basic type of expression which will only extract a parameter and save it within the property. Let's go ahead and create something nice now, which is going to be the amount of blocks we have in this wall. Okay, you got the base data over here, which is number of blocks in 1 square meter, is equal to 11.425 blocks in 1 square meter. Keep in mind that the blocks measure 15 by 20 by 40 centimeters, so this is 14 by 20 in height. Okay, and we also consider the value of the joints. We discard the measurement of the surface area of the joints in this square meter. Okay, let's go ahead with this value. What we're going to do now is something more interesting. Let's create a new property right over here. Let's name it amount of blocks. I'm simply going to set this to number of blocks in parentheses 15 by 20 by 40. Okay, let's press OK. So yeah, now what we can do is, how about we take the previous property, we link the previous property for this new property, and we use an operator. Okay, so let's go ahead with, first off, let's select the property. Let's set this to an expression. It's going to open up the expression editor. And now in parameters and properties, let's proceed, find the property we just created, which is the wall surface. Okay, you can even link the same property over here. I don't really think, yes, for some reason it's possible, but it's not going to make a lot of sense, but okay, whatever. Okay, let's go ahead, let's add up the previous property we have created. So it's going to take the value of the previous property which is expressed. Keep in mind that this value is the units for this value is in square meters. Okay, now what we can do is simply press the operator function over here, the operators, and now you can find all types of operators. Whether you want to use some type of true, false condition, you can go ahead with basic operators, add, subtract, multiply, divide, power, equals, anything you want to use. You got logical functions, okay, mathematical functions you can use, trigonometric functions, statistical functions. You can get the average of something, which is quite nice, specifically if you want to get the average of a price. Okay, you got text editing, whether you want to trim text, split the text, or whichever function you want to use. And you got data conversion, which will allow you to convert from a number to string, from a unit to string, or anything to pretty much to a string type of data. Okay, for this case, we only want to take the area we have measured, which was something like 17 point, I don't really remember, 17.25, and we want to multiply this area times 11.4, if I remember, maybe 2. Okay, I'm just going to set this by 11 blocks. Okay, this is going to give us the total amount of blocks we got for this wall. So this is pretty basic type of operation. Let's go ahead, operators, and we use the multiply. Even if you set the mouse over here, ArchiCAD will explain everything to you. The key, you can use this small asterisk to mark the multiplication. It's going to give you argument types, results, more info. Okay, let's simply, you can simply press the asterisk. That's one way to input this operator. And another one, which I prefer a little bit better, is going to be simply to double click the operation. Okay, simply double click it. It's going to add the small operator over here. And we're going to multiply this times 11.425. Okay, 11.425. So we could say that we are pretty much done with this function, but there's one more thing that we need to solve. Let's press OK for now. Remember that this unit is in square meters. So the logical operation here is that if we multiply square meters times 11, we still get square meter type of unit as a result. Okay, where in reality, what we get over here should be a number, not an amount of blocks. This is not expressed in square meters, it's expressed as a basic number. So what's going to happen here is that if we set this to a number, it's going to give us an error. Hey, this doesn't really work. You need to evaluate this, okay, and you get an error over here, which will tell us the expression conflicts with the property data type. So yeah, it's going to mess up the property, okay? We could say that this still behaves as an area, and yes, it will work perfectly fine. You could go ahead and set the data type to area, okay? But a better way to solve this would be to simply go ahead, let's edit this expression. Let's input everything inside a parenthesis, okay? You can always use parentheses. And let's divide everything by 1 square meter. So the result is going to remain the same in numerical values, but the data type, if you divide 1 square meter times, divided by 1 square meter, this will cancel and you get only a basic number, okay? This is how it works in ArchiCAD. So yes, this is the logic we expressed in ArchiCAD. Let's go ahead with division. And let's apply a small trick. 1, 1, okay, set it as 1, and let's go ahead, area and square meter, okay? So yeah, we're going to take the wall surface, multiply this, and then simply divide everything by 1 square meter. Press OK. You can notice now something interesting going on. We set this to area, which before the change, it worked properly, but now it's giving us an error. And when we switch again this to number, there we have it. As you notice, everything now works perfectly and the data type is correct. This is a number of blocks, okay? And we started out with square meters, we multiply and then cancel the unit by simply dividing this with this small trick, okay? You can always go ahead and convert everything to another type of data using more operators or the data conversion function, but from experience this is my preferred type of solution for this particular case, okay? So yeah, let's test it out. We got number of blocks. Let's press OK, and let's now edit the tag we got over here. I'm going to add another field which is going to be number of blocks. And let's add a new auto text, which is going to be the property we just created. For some reason, it's not going to give us... okay, let's see if this can update. Yeah, we haven't... yeah, this is something I will always forget. Let's go back to Classification Manager, and we need to update this. We need to make the new property also available within this classification. So don't forget to make adjust the availability. Okay, let's press OK. And now let's test it out once again. And there we have it, amount of blocks. And we simply add a suffix over here, which is going to be the blocks. So yeah, this is how it's going to work. If you now switch the measurement for the wall, this will update automatically. You need 40 blocks to build this wall. If we switch this wall over here, it's going to tell us you got a surface area of this, and you need 95 blocks in order to build this wall. Okay, so which is looking quite amazing. If you count all the blocks individually over here, you will get the amount expressed over here. Okay, so as always, take a moment, check out this next property. And now we can proceed with the rest of the properties, which would be, we're still missing the amount of mortar we need for the walls, the amount of cement, the amount of lime, the amount of sand and water. Okay, so we're going to pretty much from now on apply the same formula we used over here, but in order to quantify mortar and all the components that generate the mortar. Alright, so for this case, let's go ahead and simply quantify the amount of mortar we require for the wall. In 1 square meter of the wall, we will use 0.088 square meters of mortar. Okay, we multiply this by the thickness of the wall, which is 15 centimeters. We will get that in 1 square meter of the wall, we require this amount of mortar in cubic meters. Okay, so let's go ahead and create the property for this case. In long story short, what we're going to do is we take the square meters of mortar, we multiply this by the amount of mortar we got in 1 square meter, and then simply multiply this by the thickness of the wall in order to get the final value, which is going to be volume. Okay, so let's go ahead. Once again, property manager. Let's create the next property, which is going to be called mortar expressed in cubic meters. Okay, let's press OK. And it's going to be an expression. Okay, the expression is also going to take the base parameter wall surface. So let's input that real quick, which is going to be the wall surface. Then let's go ahead and activate the operator, which is also going to be a multiplication. And we multiply this, we set something like 0.088. I'm going to double check this just in case. 0.088. Yep, it's completely correct. And now finally, let's put everything inside parentheses and take a moment to multiply this. Yeah, I need to first off add the operator, multiplication, and now the thickness of the wall. So we get the amount of mortar in cubic meters. We multiply the surface times this, and we get the cubic meter. Okay, so the final result should look, yeah, we still need to fix the data type because the final result should look like a volume. Okay, let's press OK. Let's see if we switch this to volume. Most likely we get an error. So we still need to fix this real quick. Okay, so how about we do this? We got the wall surface, which is square meter. If we multiply this by meters, okay, we will get as a final result cubic meters. Okay, this is the logic in ArchiCAD. So you can add meters over here or over here, however you want to manage this. I'm just going to add meters at the very end. Right over here, let's see, we got length, meters, and let's see if this fixes the issue. And yes, so we got the volume, and now the data type is correctly expressed. Okay, so I'm just going to add meters over here, and we finally get the correct result. Let's press OK, and let's finally test the value with the tag we got over here. Mortar in cubic meters. Let's add an auto text. Yeah, I'm still missing the, it's always the same. I'm always forgetting to update this, the availability. So let's add this real quick into the classifications. Mortar, press OK, and let's now test the value. Let's add mortar. And this is going to be expressed in cubic meters. Okay, so as you can see right over here, it works, everything works perfectly. Let's switch this wall. It's going to update the amount of blocks and the amount of mortar you require for this wall. Okay, so as always, take a moment, make sure that you get the amount of mortar you require for your project. And now we can proceed with the components that integrate the mortar, which is pretty much the same. We take the amount of mortar and we multiply or divide by something, and we get two values in this case. Right, so having gotten the amount of mortar we require for the wall, let's proceed with its components. And what we want to do is we will take this information that you can find in your brochure, 1 cubic meter of mortar, which is in this proportion, cement, well, this is still in Spanish, I apologize for this, but cement, we got lime, then we got sand and water. For 1 proportion of cement, we will use half of proportion of lime. We use 3 proportions of sand and 0.6 proportions of water. Okay, so in 1 cubic meter of mortar, we will use around 320 kilograms of cement, 78 kilograms of lime, almost 1 ton of sand, and this of water. Okay, feel free to adjust everything always to your own proportions, to your own liking, but I'll just take this data for the exam. Just in your region, we refer, we refer over here packages, bags. You can also call these lumps, if I'm not mistaken. So let's consider that a bag of cement will also measure 50 kilograms. A bag of lime will measure 25 kilograms. A bucket, or we could say bucket, can, or canister, however you want to call this. A bucket of sand, we will consider this a 19-liter capacity for the bucket, and the same for the water, 19-liter capacity of the bucket. So what we want to do is we will get the amount in kilograms, how much cement we require for the mortar, and then we take this measurement and we simply divide this by 50, so we get the final amount of bags we require for the mortar. Okay, so first up we will try to solve the amount in kilograms. Okay, so let's proceed with kilograms. Let's go over here to properties and let's create 2 new properties, one of which is going to be cement kilograms. Okay, and then let's create another one which is going to be cement bags, that 50 kilogram bags, let's call it like that. Okay, let's proceed first up with the first value, which is just in plain kilograms. Let's go ahead with the expression. So what we're going to do is we'll take the property we already got, which is mortar in cubic meters. Okay, so we got the measurement of the mortar, and if I remember, we divide this at the end, but for this case, let's multiply. We multiply this times 320 kilograms. Okay, so let's go ahead, 320. Now we need to fix the data types because we still over here got cubic meters, and this is going to be expressed in kilograms. So we get an issue over here. What we want to do is cancel out cubic meters, so everything is expressed as a number, as a basic number, which we are going to take for the final value. So let's put everything into parentheses, and let's see if we can divide this, maybe divide this by 1. Okay, and this is going to be a cubic meter. If we divide this by 1 cubic meters, we get the final result in number. Okay, let's press OK. And let's set this to number. Okay, so everything's looking good. Just going to double check this with my solved exercise over here. But yeah, we multiply this times 320 and then divide this by 1. Okay, so now we got the mortar, we got the amount in kilograms. Let's test it out. As always, let's go to classifications. Make the new property available. Well, let's make both of these available altogether. And now let's see if this works correctly. Cement, kilograms. Let's add the property. And yeah, it makes sense. For this wall, we will need only around 1 bag of cement. Keep in mind that this value is not considering the waste. We usually consider 5% waste, between 2 and 5% waste. This depends upon each individual criteria. Okay, but looking good so far. If we switch the measurement of the wall, this will update accordingly. So far looking decent. Okay, let's go ahead with the second property, which is getting the amount of bags we got for this wall. Let's go ahead with expression. Let's take the last value we have created, which is going to be, in this case, cement. Okay? And what we're going to do is we simply divide this by 50. Because if you remember a bag of cement, keep in mind this also depends upon the region. But in my case, I'm going to set 50. Okay? Yeah, we still got an error for a reason. But we simply take a number, divide this by 50. Just going to, okay, no spaces. Let's see if we got no spaces. And let's set this as a number. So yeah, looking good. Looks like it's working perfectly. Okay, I'm just going to double check just in case. But yeah, we simply divide this by 50 and we get the amount of bags we require of cement. 50 kilogram bags we require for the wall. So let's go ahead. Let's integrate the value over here, cement, amount of bags, 50 kilogram bags. And for this wall, we will require the final value, almost 1 bag of cement in order to build this wall. Okay, without considering the waste, which is 5%. If you like to consider the waste, you can always, for example, take the previous measurement, edit this a little bit, and maybe multiply this times something a little bit higher. Maybe let's see, we can get 5% of 320, which is going to be 16 more kilograms. So we can maybe multiply this 336. Let's see if this works properly. So yeah, there it is. Instead of 0.75, we require now 0.79, considering a waste of 5%. Okay, so this is a quick fix on how you can consider the waste. But for this value, I'm just going to keep it. Let's say that the worker works extremely perfect. Let's set this to the original value. Okay. But yeah, with this, we can say that we now have finished getting the amount of cement in kilograms and in amount of bags. Okay, so take a moment, make sure that you get the first component, and now for the next lesson we can do the same with lime. So once we have cement in kilograms and bags, the process is pretty much the same for lime. Let's do it a little bit faster now. What we can even do, and what we could try, is to duplicate everything, but no. Yes, actually yes, it's going to allow us to duplicate everything. So let's simply take the cement, duplicate this, rename this to lime in kilograms. Okay, let's move this lower, below the cement over here. And for lime, what we can do is simply go ahead, double click this and edit this just a tiny bit. So instead of 320 kilograms, we will require around 78 kilograms of lime, if I'm not mistaken. Okay, you can always consider whichever value you want to use. I'm just going to take it as it is, not going to worry about this too much. Let's go ahead and set this to 78. And there it is. Okay, now let's once again duplicate the bag value or property over here. Okay, and double click it. Well, in first place, let's rename this so we can know which type of value we got over here. This is, instead of cement, it's going to be lime, and the bags will weight 25 kilograms. Okay, let's double click this, and we will, instead of cement, we want to take lime. Okay, the lime in kilograms, and we divide this by 25. So in theory, if you notice, this was much faster, should work properly. Feel free to always adjust this value. I'm not so sure about this value, but feel free to adjust this however you want. Let's press OK, and let's finally test the final value. Let's input lime in kilograms, and then lime in 25 kilogram bags. For this lime, we add the auto text, which is going to be this one. And then we add another auto text, which is this one. So yeah, for 37, we require 37 kilograms of cement, a little bit of lime, and then we got the final result. Well, it actually looks okay because we got a proportion of 1 of cement and a half of lime. So yeah, these are the values that is going to give us, looking decent, and pretty much we're done with the lime. So take a moment, make sure you fix, you are done with your lime, and then we can move on to the last one, which would be the sand and the water. So for sand and water, the process remains pretty much the same. So let's go ahead with properties. And what we want to do is get the amount of kilograms, okay, the amount of liters, and then finally the amount of cans, canisters, or buckets in 19-liter buckets. Okay, so let's start off with sand. In 1 cubic meter of mortar, we will require around this of sand. Always feel free to adjust this value however you want. Let's go ahead. I'm going to duplicate the value so it's much easier this time. Okay, let's go ahead. Sand in kilograms. We got 1 square meter of mortar. Let's multiply this times 1052.67. Okay, so this is a different value, something like this. Going to double check this just in case. And yeah, it's looking good. Okay, so the first value is pretty much done. Now we duplicate the division, okay, which is the second value. Let's duplicate this, rename this sand, 19-liter buckets, okay, and then finally but not least, let's move this around over here. We need to adjust this a little bit. Instead of lime, we switch this to sand in kilograms, and finally but not least, we divide the sand by 35.1 buckets, cans, or canisters, however you want to call them. Okay, by 35 buckets. So let's leave it like that. Sand kilograms, we divide this times by 35, and yeah, we pretty much are done with the sand. Now let's go ahead with water. Also, we duplicate this. Let's rename this water, but this one is going to be expressed in liters. It's also going to be a number, so let's proceed with water. In 1 cubic meter of mortar, we get 133, we require 133 liters. So let's go ahead with water. We take the mortar and multiply this by 133. I'll double check this just in case. There it is. So yeah, pretty much done. Let's duplicate the buckets. Okay, move this around. Rename this to water, 19-liter buckets. And then finally but not least, once again, we can divide this. We take the water in liters and we divide this by 19. Okay, so if a bucket has 19 liters, we divide the total in the capacity of the bucket, and we could say that we're pretty much done. Yeah, because yeah, we get, well, it's 133 liters or 7 buckets, 7 of 19 liters. So in this case, we simply divide this by 19. And for the sand, if I remember well, we divide this by 35. That's the amount of buckets that will hold around this amount of kilograms, okay? So yeah, let's finally put everything to the test. I'm going to add the extra values. So we got cement, we got lime. Let's go ahead with sand. And yes, it's going to look reasonable. Of sand, we require around 3.5 buckets. Of water, we only have 15 liters, which is around almost 1 bucket. It's looking good. It's working properly as intended. And yeah, we are pretty much done with the hard part, which was the creation of the properties. So now if we change the wall, we adjust this however we want. Let's create a segment over here. It's going to quantify the amount of components you require in order to build this wall. Okay, if you notice, it's going to be also connected. Yeah, it will completely change, and we can say that there it is. We're pretty much done with the property programmation. So as always, take as much time as you require. make sure you create all the properties that will get the components for this wall. And now we can get into the final details, which would be creating all the tags for each of the walls, and finally summarizing the information to get a total through the use of schedules. So let's go ahead with the final results. We are pretty much done with the harsh part. Let's go ahead. Let's simply move this around a little bit, maybe here. Okay, whatever. Let's take the droplet icon over here, the pickup parameter function over here, and make sure you pick up the parameters for this tag, because what we want to do is we want to save the configuration of this tag within the tag tool. Okay, so now what we're going to do is apply the same trick I already explained in the course of constructive solutions with ArchiCAD. Let's select the wall over here. Let's press Ctrl A to select all the walls we got in the project. And now we jump into document, annotation, and we got this option, which is label selected elements. And what's going to happen is that it will automatically assign the tag for all the walls of your project. Okay, so we can, for example, take this one, move this around, maybe this one. I'll just take a minute, order this a little bit. And there it is. I would almost say that everything works perfectly, but you can clearly notice it's not working properly. And that's happening because we are still missing a small detail. If you remember, at the very beginning, we made sure to classify correctly these walls. So we need to do the same for the rest of the project. Let's select this wall, this one over here, this one. Make sure you don't select any confinement element because we're not quantifying the confinement, but you can always use the same formula to quantify, for example, the amount of rebar, the amount of steel, the amount of concrete you require for building a beam, a column, confinement elements. It will be the same workflow. Okay, let's select all the walls and let's make sure that we assign the correct classification, which is going to be the hollow concrete block wall. So it's going to create the properties, press OK, and now let's see if it's going to update. And yes, it's actually going to update. So it's going to tell the first wall has around a surface area of 10 square meters, and it will require this amount of components. 115 blocks, 42 kilograms of cement, and pretty much the rest. For the second wall, it's going to switch the amount. So yeah, it's looking quite amazing for the tag. Okay, so having made sure that the tags are now set, let's proceed with the final detail. Let's take all the information we got over here and summarize this in a table. Okay, so let's go ahead, elements, right click it, new schedule. Let's create a quantity, number 1. Wall, let's name this wall components. Okay, for wall components, what we're going to do is we're going to select everything that is a wall, as simple as that. And for the fields, we want to include the ID, element ID, and then we proceed with all the different properties we have created. Okay, I'm just going to double click pretty much everything. You can also select with Shift and simply hit the button of add. It's much faster. Yeah, I should have done that instead of double clicking everything. Okay, finally but not least, let's sum up the total of blocks, the total of mortar. I think we actually need the total for everything. Let's see if we can apply the same trick over here. Yes, we can. So let's get the total of everything. Okay, so yeah, it's looking good. Let's press OK. Let's open up this schedule. As always, we want to merge the items in first place. In second place, we click this small icon over here and activate the resize columns and resize rows command. Okay, and now I'll just take a minute, give this a little bit of format using the text style and background options. And there it is. We can say we are pretty much done. So we got in total 43 square meters. We require around 500 blocks, around half a cubic meter of mortar, around these of kilograms, around these of bags, these of lime bags, around these of sand, and these of water. Okay, so we got the final totals in order to build the masonry for this project. So hopefully with this, it is completely clear how you can use expressions for more advanced type of quantifications. Even if we use simple formulas, but you can notice that you can pretty much start quantifying pretty much any type of element for your project. And feel free to use expressions to your own advantage, however you want. You can clearly see that this is almost the same as using Excel, but inside ArchiCAD, because we got the same formulas. You take one data of ArchiCAD, reference this to create something else. Okay, so hopefully with this it is crystal clear the potential of expressions. As always, take as much time, practice this as many times as you require, and with this we can now put an end to this section. As you have seen, expressions opens up even more possibilities, especially when it comes to managing non-graphical information. You can now start linking both basic and advanced formulas to the core data generated by ArchiCAD, which in theory allows you to estimate or even partially or fully budget a project directly within the software. In the next module, we'll shift to a different topic where we will explore how to take advantage of artificial intelligence to enhance the visualization of our model. But we'll have plenty of time to talk about that. As always, take a short break before diving into the next section, and having said that, I'll see you in the next module.